Hi all, I'm here to help you through Lab 5, Organic Compounds and Functional Groups. Turn to page 33 in your lab manual. Functional groups are really important for macromolecules, hydrocarbons, because they allow certain characteristics and functionality for the molecules, particularly hydrocarbons. Here is a hydrocarbon. So anything that has a hydrocarbon with an OH attached it's called a hydroxyl. So in the gray is the hydroxyl. So I made a hydroxyl for you, and this is the hydroxyl molecule. This is what it would look like if you were to build it. Right? Here's the O and the H. The red is oxygen and the yellow is hydrogen. The next one is an aldehyde. An aldehyde has a carbon attached, double bonded to an oxygen, with a hydrogen also attached to it. So let me get that molecule for you. Here it is right here. And when we're building molecules, because there's a double bond, meaning they share two pairs of electrons, we use a spring to show that. So here is the oxygen in red, carbon, and hydrogen. The next one is this one over here, which is a ketone. A ketone has a carbon and an oxygen, as you see here, double bonded. That's what the two lines mean. In here you see the two lines showing that they share two pairs of electrons. So ketones are really important because, you know, they, for instance, are in nail polish and help remove nail polish, so that attraction is there. Here's a carboxyl group. A carboxyl group has a carbon linked to an oxygen, and so I believe, let me see where my carboxyl group is. Oh, here it is. And I lost my hydrogen. I know I have a hydrogen around here somewhere. Oh, wait a minute. Here it is. So it's attached sort of like this. Wait, hold on. I can get this done. It's a little bit of a pain. Here it is. This is one thing about these things, they fall apart really quickly. So that's my carboxyl group. And then, of course, I have my amine group. So I use blue to represent nitrogen and the two hydrogens there. And then my phosphate group is this over here is my phosphate. So gray represents, oops, here's the gray, represents the phosphate. And here this is, I think this is supposed to be, I think I lost an oxygen here, but you get the idea. And here we have the sulfur. And then finally we have the methyl, right? So this is methyl. This is this is sulfur-hydryl. Okay, so that's what you're supposed to be making in class, and that's what that is. So there's a couple of things here, like, is water an organic molecule? So anything organic has carbon in it. Well, water doesn't, so that should help you answer that question. So here we are down here where we're building a glucose molecule. We already saw the glucose molecule in class, if you can recall. So let me go get the glucose molecule so I can show you what the glucose molecule looks like, if you can remember. It's this large molecule over here. This is the glucose molecule. Right, so I'll bring it over so you can see it. Okay, so this is the building block. So this way, this is the building block for carbohydrates. And what's really important is that it's made up of carbon, oxygen, and hydrogen, and usually a 1 to 2 to 1 ratio, right? 1 to 2 to 1 ratio, okay? So that's that. Okay, so what is the difference between condensation and hydrolysis? I'm hoping I can explain that to you. I'm going to do my best. Okay, so building a lipid, so what they want you to do is build this glycerol molecule. So here it is right here. Here's a glycerol. And I want you to see here the 3 carbons. Here is the oxygen. Over here is another oxygen. And here are the hydrogens you can see attached. So this is what we call a glycerol. It's a part of a lipid. And so what they want you to do is remember organic acids contain carboxyl groups on one end. So that's what it says here. So let's see, where can I find my carboxyl group? So it looks like this is my carboxyl group. Okay, so here's my carboxyl group. So then it says fatty acids have an even number of carbons in a long chain, while these molecules usually contain 12 to 20 carbons. Other number molecules to occur. Construct chloric acid from the structural formula below. So here is my hydrocarbon chain right here. And I'm going to do the best. This is it. As you can see, it's quite large. Right, so I have 1, 2, 3, 4, 5, 6. 6 carbons, and you can see all my hydrogens attached. And here is this attachment over here. Of course, I messed this up because that's what you do in these kinds of things. Let me see if I can construct it for you, and that way I can show you that molecule. Okay, be back.